How are you doing? This is Mike Johnston here, and in this video we're going to talk about increasing, decreasing, and constant functions, or maybe even more specifically we can talk about where the functions increase, decreasing, or where they're constant. So when we evaluate these different functions, increasing, decreasing, and constant functions, we're often going to see that in these circumstances there's going to be a portion of your graphs where your function is increasing and then it's decreasing, or it could be constant. It doesn't have to be just increasing, decreasing, or constant. So if we were to examine just a portion of a function, let's go ahead and say we have a linear function that looks something like this. So the linear function looks something like this. So notice how it's traveling from bottom left to top right. And I'm going to go ahead and call this red line, we'll call this just a general function f of x. We're going to say that f of x is increasing, it's increasing, and then we have to describe the interval on which it's decreasing. So if we notice here, these arrows indicate that this function is traveling off to negative infinity, and then over here we say this function is traveling off to positive infinity. So when you describe an increasing function, we say that it has to be increasing on some interval, and this interval is usually described as an open interval. So for right now, because this function is continuously increasing, we're going to say f of x is increasing from negative infinity to positive infinity. So we're going to say f of x is going to be increasing from negative infinity to positive infinity. Let's go ahead and examine another function. So in this function, we're going to have something that opens up, and then it's going to be leveling off, and we're going to say now it curves down like this, and then at this point here we're going to say this function shoots off like that. And these arrows at the end of the function are indicative that it continues on to infinity. And I'm just going to label some random points. These are just going to be some random points. I'll call this point right here 1, this point right here 4, this point right here, we'll call this point right here 6, and over here we'll call this point negative 3. So negative 3, 1, 4, and 6. Let me make sure we can see this value of 4. And here we're going to ask, where is the function increasing? Where is our function increasing? So in this circumstance, we're going to say, okay, where in my function, where in this graph is the function going from the bottom left to the top right? But remember, we always must describe, so let's just make sure we make a little note here. You always must describe where the function is increasing. So in our last example, we saw it was continuously increasing. So we said that it was increasing from negative infinity to positive infinity. However, clearly here there are portions where my function is not increasing, where it's not going from bottom left to top right. So what I often like to do is that I often like to draw, I'm a very color and visual person, so I like to draw and note in my function where I see it increasing from bottom left to top right. So if I highlight this here, I'm going to highlight that it's going up from bottom left to top right at this interval. And then as I travel from 1 to 4, as we travel from 1 to 4, so as we travel from 1 to 4, we see the function is not increasing. Actually, from 1 to 4, this function is constant. It's not increasing or decreasing. From 4 to 6, our function is going down. It's sloping down. It's not even linear. It's going to be a nonlinear portion of our function. And then from 6 on, we see our function is going back up again. It's traveling from bottom left to top right. So in this circumstance, we're going to say our function is increasing again. So as we describe our solution, we read our solution going from left to right. So we're going to have to describe our solution going left to right. So over here at the edge of my graph, I call this value negative infinity. As I travel very, very far to the left, we know we have a value of negative infinity. So my value starts increasing from the interval of negative infinity until negative 3. We never enclose infinity or negative infinity with a set of brackets. We always enclose negative infinity with a parentheses. In fact, negative infinity is just an area. It is not a finite value. It's just an area that describes a very, very negative portion or a very, very negative number. Oh my goodness, excuse me. So in fact, it's not actually -3. We are not increasing until -3. We're going to go past -3 and we're going to increase until 1. So I apologize about that. We are not increasing until -3. We're going to surpass -3 and we're going to go all the way out here until +1. And when we describe this interval at this point right here, our function is neither increasing nor decreasing. He's actually constant. So we always enclose our intervals with a parentheses. We're going to enclose our intervals with a set of parentheses. So they never ever get enclosed at the bracket, because at this point right here, so I'm just going to highlight this and say the function is neither increasing or decreasing. So the function is neither increasing or decreasing, hence why you're always going to enclose it. So we always enclose with a set of parentheses. So we're going to enclose one with a set of parentheses, and then we see over here that my function at 6 starts increasing again. It starts increasing again. And then it continues increasing all the way out here, and we call this value positive infinity. So then it increases from 6 to positive infinity. At 6, our function is neither increasing nor decreasing, so he starts increasing, so we're going to enclose him with a parenthesis. And then at infinity, we always enclose infinities with a set of parentheses, so it's going to have a parenthesis as well. And notice we have two different intervals. Where our function is increasing. So we have to describe where this function is increasing jointly. So we join these intervals with a u. So we're going to join these intervals with a big U, and that's a symbol that says that this interval does not exist by itself. We're going to take the interval from -infinity to 1, and then it also increases from 6 to infinity. So that big U stands for union, and it means we're joining two different intervals. This is an example of where we're going to see an increasing function. In our next video, we're going to describe where our function is decreasing and then also where it's constant. There is a more formal definition that you're going to see probably in class or in your textbook, and it describes a value of a and b, and then there's a function that exists, and in order for the function to be increasing, there's a value a which is less than b, and it's much more algebra-like. It's much more algebraic. It's a much more formal definition. But in this video, I'm just going to be able to look at a graph, and we want to describe where our function is increasing, and we clearly see that it's increasing from where the portion is highlighted.